All right. Well, welcome back to Advent of Code. This is probably a little bit small. We've got about half an hour before the problem opens for the first time this year. This year, there are only going to be 12 days or 12 problems. If you're interested in why, there is an answer in the FAQ, so I'll let you go read that if you're interested. And let's drop into a terminal and try to do a little bit of prep work before we get started here. So every year, I kind of throw everything into this one repo. I will leave a link to this repo in the description of this video. We've got everything from, 2017 when I started doing this for the first time, all the way through to 2024. So no matter what, my first step is to make a 2025 folder. If I can type makedir correctly, we're off to a great start here. So let's get into that directory. There's nothing in it right now. I was thinking a little bit about what I wanted to do this year. I haven't really had that much time to prepare for Advent of Code this year. Typically, I make a big starter video and whatnot. I'm not really sure what the experience is going to be like this year. So typically what I do is I have this daily template here, and then I use Cargo Generate. Cargo Generate is a wonderful kind of like project scaffolding tool, if you will. If you tend to make a lot of projects, I highly suggest it. It works really well. But one of the cool things that you can do with Cargo Generate is just have a folder locally and say that I'm going to use that local folder as my Cargo Generate template. So we've got this just command here that is Cargo Generate with that path to daily template and the name of the day. And then we've got this secondary script, which is a nice user experience improvement. If you are familiar with Advent of Code, you know that you have to go to the website and get your own input every day. So this is a script that will grab the Advent of Code input for a particular day and put it into a specific directory. So these two things are kind of the most valuable commands or tasks that I have in this just file. Everything else is more or less things you can do with just cargo or cargo watch or cargo next test or however you want to set up like a Rust project, right? Actually don't really know that I mentioned it, but I'm doing them in Rust again this year. So let's make a Rust directory. It's kind of like year language as a directory setup for me, just in case I want to come back and do something in another language sometime. Nothing's been calling out to me lately, so I'm still doing them in Rust, but I've done other languages in the past. So I do have setups for benchmarks. I do have setups for each of the days. And I was thinking about this setup a little bit. So this daily template here is a couple of things. There's a lib.rs that has two modules, one for part 1, one for part 2. That is this file and this file, which you can see are like extremely similar, right? It's basically the same code. There's this process function. It takes a string slice. It returns a result. This is really nice because it lets me use the question mark if anything goes wrong instead of having to unwrap everything. And I do occasionally like writing tests for different things, especially on maybe some of the harder problems that I want to break down into pieces. But I tend to use these tests as the examples that we get for the first problem. They give you a couple of test cases. I usually put those test cases here and run the function against them for part 1 and part 2. Now, having these two modules, the setup for running them is actually pretty much exactly the same too. So part 1, part 2, right? You can see how these files aren't changing as I flip back and forth between them, hopefully. But it basically just grabs the input, processes it, and then gives you the result. The error handling library that I use isn't yet. It's nice. I like it quite a bit. And then I've got some like minimal set of dependencies that I tend to use. itertools is a common one for me, so I usually install it. The parsing in Advent of Code isn't typically very strenuous parsing, but I do still like using a parsing tool just to get some reps in. Tracing tends to be very useful in all use cases. I like having info and the debug sigil and things like that we'll see as we go through these problems. And then we have a couple of things here that are for benchmarking. That's Devon. For test cases, that's rstest, and test log is for running tracing output or outputting tracing output even when tests are running. And then we've got a couple of benchmarks. I don't always write benchmarks, but sometimes I do, and I like to have everything set up like this so that there are, tests for each of the cases that we get for each of the problems, binaries that we can run for each of these, and then benchmarks that I can write. And what I tend to do is I'll go back for a bunch of these and write different solutions in different approaches, use different libraries, use no libraries, use like anything that I want to do basically. It's just another binary here. Copy this scaffolding, drop it into like part one underscore, whatever the next attempt that I want to make is. And I like that. So I think for this template, it is kind of, if you're just trying to get through this as fast as possible and you're trying to do as little as possible and you're trying to use no dependencies, this is a little bit of an overkill template. But for me, and what I like to do, which is basically have a number of binaries, have a number of different attempts, play with the problems a little bit more, have some benchmark output for the different approaches that I take, be able to compare the different approaches back and forth or write some tests and whatnot. This is what I like to do. It's panned out pretty well each year. I have all the videos for the past years on this channel as well, so you can go check those out if you want to. So I think we're going to keep this template, and then I think we have a couple of updates to do. We have this get AOC input. This is actually cargo script is what it's called. So you can kind of write CLI tools in Rust, which is nice because some people actually do end up copying this repo and playing with the stuff inside of it. So it's nice to know that wherever Rust runs, they can use the scripts that I write as well. I tend to keep a benchmarks.txt file here for quick looking at some benchmark stuff, but I don't always do benchmarks. Day 11, actually. So I think we'll copy a couple of these things over into 2025. I think especially the daily template makes a lot of sense. So we've got that daily template in now. And then I think I also want the scripts. I'll take the just file for now, but I'll probably get rid of a couple of things. And then I think the cargo toml is also probably getting pretty important here. Because other people tend to play with stuff, I think that I might pull the Rust format in here as well. And I think we're good with the Rust toolchain to not have one. We used one last year because at some point I decided we were going to use nightly. And when you use nightly, it's nice to pin to a specific version. But I think we're good. Back out of all of this. And this is what we end up with in 2025. We've got our daily template. We've got the AOC script. We've got a cargo toml. Workspace resolver is up to level 3 is what I was going to call it. But it's up to resolver number 3 these days. So we'll bump that up. This is called kind of a workspace or a cargo workspace. So every day, if you see the days in 2024, right? Day 1, day 2, these are all separate packages that are inside of a workspace. I do really like working like this, so I'll continue to work like this. I think we can just, I don't know that we need glam per se. It can be useful. Maybe we'll install it when we need it. I feel like there's a reasonable amount of vec2s and positions that come up each year. Iter tools, also very useful. Not everything that is on the iterator trait in Rust is stable. So there's things on certain types, like I think array windows is one of them, and other things like that. What I find myself using the most from iter tools, I think, is probably tuple windows. Tuple windows allows you to take a window over a vec. So let's say you've got the numbers 1 to 5 here. It takes this tuple, it infers the length of that tuple, and then gives you sequences of 2 items. So 1, 2, 2, 3, 3, 4, which is really nice. So there's a couple functions like this. I like Cartesian product as well. There are a couple of things like array windows on slices. But again, array windows is a nightly only API for Rust right now. So if you want to do this kind of thing on stable, you kind of have to use iter tools at the moment. Otherwise, if you're comfortable using nightly, you can use array windows, and that uses const generics, which is really cool. But I do like when I iterate over things like this to have, a specific size and not just an arbitrary size to slice. So that's where iter tools comes in. Nom is something that I tend to use quite a bit. There's a couple of other options. So nom is a parser combinator library. It's up to version 8.0 at this point, which is really cool. If you've watched my Advent of Code videos in the past, I use a lot of nom. I like nom quite a bit. There's a couple of other parser libraries. Winnow would be another one. It kind of forked off of nom and then made some changes. You can see that they even use the same exact example in the README. There's also Chomsky. There is also Pest. Pest is kind of cool if you're used to using like EBNF grammars and stuff like that. It actually comes with a, oh, that's not what I meant to click on. It actually comes with a VS Code extension that can do some validation of this grammar and a playground, which is really cool as well. So this is actually an interactive playground here. Actually, this is something that this is from one of my last Advent of Code problems. The last time I was on this site and dumped in some some best stuff. That's really funny. But you get a lot of options. There's also options for regex. There's the libraries used by ripgrep that you can use, and so forth. There's a lot of parsing options. Rayon is really nice to just get like some quick performance wins if you kind of need them. rstest, I think we'll just get rid of for now. I know it's in the template, so I'll have to get rid of the template. Actually, you know what? We're going to keep rstest. We're going to keep rstest specifically because I know that one of these days there's going to be a set of cases, and this is good for table-based tests. I don't know that rstest for use is something that we're going to use, so we'll get rid of that for the moment. Are we up to date on? I think we are. Nom locate is up to 5. I don't know if nom supreme got a release. Nom greater than or equal to 6, less than 8. So if we use it, we can't use nom supreme. That's totally fine. So we'll get rid of nom supreme. And then I think that's fine. That means that we've got itertools, nom, tracing, and yet as our kind of like core dependencies for every day, which I think is fine. rstest, devon, and test log for sort of testing, benchmarking, and things like that. Just checking my time. The one thing that I do want to do here is change 24 Rust edition. That has since come out. So we will use Rust 2024. These two input files are blank until we fetch them. They don't get committed. I have committed them in the past, but there were requests to stop committing them, so I stopped committing my input files. This also needs to be 2024. Let's just bump the dependencies on these. I think clap is a little bit higher than this, 12.20, and clap is 4.5. Let's see if this just stuff clears, and it looks like it does. So these are some of the other things to do. We'll do just create day 1. And this should fail, partially because there's a DS store. It's a Mac OS. I don't see it in a tree for daily temp. Oh, it's hiding. I think even though that failed, we're still doing pretty good. This should... Well, it's always nice to make sure things are up to date. So let's cargo install, cargo generate. I guess we could cargo bin install. The difference between cargo install and cargo bin install is cargo bin install will grab a binary from like a GitHub release if it exists, which is clearly much faster. So apparently there's some change in behavior that picks up DS store for whatever reason. And I can do just create day 1 instead. And now I've added DS store to the cargo generate ignore, and things are back and working. So now there's some issues with the fetch script since I haven't touched this since last year. So nom has had a little bit of a change here in that we need to now call parse or dot parse on the end of it. So since day 1 looks like it succeeded here, we can do just get input day 1. Oh, that's actually really funny. Okay, I was confused for a second. So we're going to bring in parser as nom parser because we actually already use clap and we use clap parser here, which we need to derive. So that is going to be, you know, an issue, which is fine. We just bring it in as nom parser and everything's fine. So now we're all set up. It's just about 9 o'clock, which means that I can log in. And once I log in, I mean to save that to Zotero. I'm going to go into edit this cookie, sneakily set up my session token, and now we have part 1 and part 2. So we should be ready to go here just, 3 minutes after the hour. Now we've got day 1, part 1. This is my input, so we're looking good here. And it's time for us to start actually writing some code. So I'll do a cargo run -p for package day 1 -bin part 1. Just let that run and compile. We don't have that many dependencies. We do have more than 0, but we don't have that many. So let's get into day 1. So the elves have good news and bad news. The good news is they've discovered project management. What is this? Wikipedia. Okay. So to save Christmas, you have to finish decorating the North Pole by December 12th. Collect stars by solving puzzles. So all the puzzles are listed on the front page. Each of them has 2. Typically the last day has 1, but we get a star for each problem, part 1 and part 2. Password was changed. Due to new security protocols, the password is locked in the safe below. Please see the attached document combination. A dial with an arrow on it. Around the dial are the number in order. Small click as it reaches each number. The attached document, the puzzle input, contains a sequence of rotations, one per line, which will tell you how to open the safe. Rotation starts with L or R, which indicates the rotation should be to the left or to the right. Then the rotation has a distance, which indicates how many clicks the dial should be rotated in. So if the dial is pointing at 11, a rotation of R8 hopefully gives it to 19. L19 from there would go to 0. Because the dial is a circle, turning the dial left from 0, one click makes it point at 99. Okay. If the dial were pointing at 5, a rotation of L10 would cause it to point at 95. Yada yada. The dial starts by pointing at. Cool. So you could follow the instructions, but your recent required official North Pole secret entrance security training seminar, so that's a mouthful, taught me that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after end. So we have to keep track of some state. So for example, suppose the attached document contained the following rotation. This would be one of our tests. Start at 50, L68, L30, R48, yada yada. They stop at 0. Because the dial points at 0 a total of 3 times during the process, password is, what's the actual password? So if we build our test here, we've got L68 to L82, and we should end up with, is the answer there? So we should be able to run our cargo test here, and we will get it failed, left 3, right, empty, which is good enough for me. So we could definitely do something pretty simple here. We could do dot lines, right? So this input will come in, right? And we could do input dot lines to get each of the lines. And then we could do, for line in input dot lines, or actually we could just do dot map. This is a line. It'll start with L or R, so we could do trim start matches. But I think trim start matches, we would still have to check. So let's see, strip prefix returns a string slice with the prefix removed. If it doesn't start with the prefix, returns none. So we could do something like if let sum direction equals line dot strip prefix L. Don't know how I'm being. Okay, so we do need to collect this as well, or operate on it or something like that. I'll collect it for now. We'll run the cargo test. Test will tell me that I am collecting into a vec with an underscore means that it will collect into whatever it is. And that will let us see our output. So we get left, left, right, left, right, left, 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 right, right, left. Left, left, right, left, right, 3 lefts, a right, and a. So this is fine. I don't love it, but it works. I would really prefer to do this with a parsing library like nom, but I figured I would show what this looks like if you didn't do that. So if we wanted to, this actually isn't direction, this, right? If we wanted to run with tracing, assuming I actually into scope, and we make use of test log on our test here, then we'll actually see the input. Here we've got a direction of left and amount to turn of 82. So these are not directions. These are actually the amount that is left. I don't know, we'll call it num turns or something like that. Then each of these needs to basically parse as something. They're all going to be positive, but we're going to end up doing math with no negatives. So I think this is going to end up being a modulus for us, like a rem Euclid effectively, which means that I think we do want to be able to go negative. So I'm going to turn these into I32, right? And like these could fail, but again, if these fail, then we're in trouble. So this is like some I32, and then we give back, L, and so we end up with this like tuple situation, R and num, and then we have directions, right? We've got a vec of tuples with L and R with the number that they need to go, which is all well and good. Now, I don't love this. This code feels messy to me. I think what I'd rather do is have an enum direction that is like left and right, and each of these could have an I32 in it. So we end up with probably something that is a parser like, we haven't used nom at all yet. So this is the introduction to nom. I'm going to call this directions. This is going to be an input of a string slice. We're going to get an I result that is a vec of directions, separated list 1. I forget offhand whether takes the break first. So it's the separator and then the rest of the parsers. So I think new line, but line ending is really what we want, right? Line ending recognizes end of line, both new line and carriage return. So it's going to be like line ending followed by like each line parser, basically, right? So we've got like an alt, which takes a tuple. This is either going to be tag L or tag R. It is kind of nice to like break this out. So we basically end up getting the same thing. Input strings I results direction. And then the first parser is just a separated list of line endings and directions. And then this is, let's see, let input dir equals that. We haven't brought anything into scope yet. I'm actually just writing this stream. So I think we have num in the workspace, right? Yeah, we have num in the workspace. So it's a couple of things I know we're going to need, like alt that we used. We used tag iResult parser. I'm sure the compiler would tell us more over here on the left. I'm not using my question marks here, which I should be. Let me also reorient VS Code, because VS Code gets confused directory. So now we get our little line endings and stuff. We want complete. We are going to get all of our stuff. So we've got directions, we've got line ending, directions, input dir alt. Then we have num, and we're going to want to get that from complete I32. Pass in our input here. So we can match dir here, or so then we have our parser, right? We've got directions. It's a separated list of directions that parses the input. And then we've got this written in a fairly standard, like line by line method. We've got an alternate between L and R for tags that we parse. We parse the I32 out. We check to see if we have an L or an R, and then we return them. And of course, I didn't implement debug for this type. So now we have something that's a little bit more structured here. So we end up with like these enums that are left in a number and right in a number in this vec, which I personally like a lot more because it means that we'll be able to match on this direction and then know what to do. We could match on the strings, but why not take advantage of the type safety if we can? So back to the actual problem. I guess this really leans towards using some mutability here. So we've got dial is 50, right? Or something like that. Now, I feel like there's a couple of ways we could do this, but if you're unfamiliar with Rust, probably the easiest way is to just do for directions and just start here and mutate this dial. So we start at 50 and then we go left 68 and we should be at 82. So really to me, this says match direction, which if you're using Rust Analyzer inside of VS Code or, you know, whatever you've got, you can use this quick fix, which is fill match arms, which is really nice because it'll just fill this in for us. And really the only difference here is whether we subtract or add. So we can do dial equals dial minus num dot rem. Hang on. My autocomplete isn't quite there. Rem Euclid. And then I think this is 100, right? So dial equals dial minus num rem Euclid 100. And then here we would have dial equals dial minus or dial plus num dot rem Euclid. And then I'm just going to info dial. So this is after everything. And we basically end up with 82, 52, 0, 95, 55. 82, 52, 55, 0, 99, 0, 0, 99, 0, 14, 30. Okay, so this is exactly what we need to be doing. All in all, logic not too terrible for part one. Now we do need to check to see if we are ever at 0 here. So just create another counter equals 0. And if dial equals 0 right at the end here, counter plus, right? And then at the end here, we do counter, and this should pass our test and fail part 2. So part 1 is now passing, part 2 is not. Let's make sure this actually works on our real input. I've already gotten my real puzzle input, but if you need it, you can click on yours here. It's useful to go in here and actually check. And actually, you know what I'm thinking of right now? This is last year's puzzle input. My get AOC looks for a specific URL, which is 25. So let me get input on day 1 here. And there's my input for both of these. It's good to check these because sometimes they throw things in like this. So if you were expecting, say, every number to be like a 2-digit number, Number 11 is not, right? There's a 2 here, there's a 1 there. I don't know. I don't think there are any 3-digit numbers here. Oh, there are 3-digit numbers. So there are 1-digit and 3-digit numbers. This is one of those things where every year Advent of Code will give you something that, like this. And this example will not have all the information in it. So in this case, we have L68, which is a 2-digit number. We have L5, which is a 1-digit number. But there is 3-digit numbers. So numbers that are greater than the number of dials, though, right? Greater than 99. Because I don't think we have any other input here. So this is always 99 or always 100 numbers, right? So really important to actually check the input. Like this is right 727, right? If you were just restricting yourself to being within, 0 to 99, then you might run into a problem there. Cool. I think it would be cool to get these to be treated like implement add for directions, but we'll leave that for now. Let's just run. So cargo run day 1 bin part 1 and hope that our output, hey, we got our gold star. And then we continue to part 2 here. So let's cover this code quickly again. We've got a process function that takes the input as a string slice and returns some result, right? This is just the way that I've chosen to set up my functions. You might have a different setup. Then we use a non-parser called directions to parse our input. In this case, I'm unwrapping it. And this directions becomes a vec of directions. And direction is this enum, which is either left with a number or right with a number. Now, these numbers happen to all be positive. I actually didn't check all of the inputs, so theoretically they could be negative, but there's a left and a right, which implies to me that you wouldn't say left with a negative number, which would then be a right turn. You never know, though, so sometimes good to check the input. Now, our non-parser here, a separated list of line endings and directions that we parse. iResult is a type alias. If we click on it, you can see type iResult with 3 generics. The error is a default. And then this is just a result. Regular result with a tuple of the rest of the input and your output type, as well as the error in the error. So we've got a result. The rest of the input is a string slice in both cases. String slice is technically slower than working with byte slices, but I'm not really going for any awards here. So I tend to use string slices myself. So this uses an alt parser, which looks for one of the elements of this tuple. In this case, it's either the tag L or the tag R, which are just literals. So we parse that first letter off, store it in dir, and have the rest of the input. We then look for an I32, have the rest of the input, have that number. We match on dir, which we know is going to be L or R, and stuff that into the enum, and then return that in a result at the end. If anything goes wrong here, if there was like a Z in the input or something, that's why this line is here. So it should panic and be like, hey, there was a Z. I don't know why there was a Z, but something is wrong. So we get this vec of directions. We initialize our dial to 50 and the number of zeros we've hit to 0. You need let mute in Rust. The default is let. Let is immutable. Mute, let mute will make this mutable. In this case, we're just iterating over directions, which gives us each of the individual directions in order. These are called inlay hints. I have it bound to Control I, which is why I can turn them on and off. If you're newer to Rust, you might not have that set up. I think I've got a short on it on the channel if you want to look for that. But when we match on that enum, we can match on either of the enums. Left is just going to be negative, right is going to be positive. And then we use rem Euclid because that deals with negative numbers appropriately. So if we were just going to do rem here, or percent, I think would be the comparable. So 1059 is our answer. It still happens to work out. But due to past Advent of Code shenanigans, shall we say, I have found that rem Euclid is typically what Advent of Code means when they're looking for a mod type operation. So in that, we don't get anything fancy here, right? This could be an iterator of all the numbers. We could be scanning over this. We could be using other iterators. We're not. We're just doing a loop, which in this case is fine. So every time the dial hits 0 after we've operated on it, we add a 1 to the counter and we have a string. And that's part 1. So part 2, you're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. Due to newer security protocols, use password method that until further notice. You remember from the training seminar that method, however you're going to pronounce this, means that you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Following the same rotations, the dial points at 0 a few extra times during its rotations. So the dial starts by pointing at 50, the dial is oriented. So if it passes over 0 or it lands on 0, both of those count. So the answer for the test is going to be careful. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Are we supposed to count that 10 times? I don't think, like, the input here doesn't have any of those cases, so that's unfortunate. Would be nice. So I'm assuming they mean count this 10 times. So let's start with grabbing everything here. There's nothing here that's like specific to part 2, except for the answer. The answer is now 6 instead of, so let's change this to 6 instead of 3. And then instead of rem Euclid. So I think what they actually want here is a div rem, which Rust doesn't have necessarily built in. If you look this up, you will find out that there are optimizations that happen in LLVM such that div and rem actually optimize to what would normally be called a div rem. So if we get the next number, we do this, we've got div and rem, and this would be equals rem count by div. And that's not quite what we need, because that gives us 5. Question being, what do we have here? 0, 0, 1, 0, not accounting for the crossover. Let's debug div and rem here. I think we need to do this count in different directions, right? So if we have dial and we're going to, I guess left is, if rem is greater than or equal to dial going left, then we're going to cross. I guess only if we're greater than, because if we need to count the cross, but not the actual z. And then here it would be, if rem is greater than 100 minus dial. No, dial's the wrong thing, because we already have rem. I turn these in. Let's also skip input for these logs. Get it a little bit. So here's all of our logs. We've got a start of 50, left of 68. This should count as going over once. And rem is 82. And really the question there is if left, which is the number we're going to move, is greater than start, which triggers quite a bit. So I think I'm using a floored div here, because this is negative 18. And negative 18 over 100. I feel like there's something I should know to like not have to do more edge case detection here. But in my brain can't figure it out this late in the day. And I think I want to write a function here that effectively takes a dial location and a I32, and I want to like dial plus rot whatever, and this returns some number, I guess. Well, this has to deal with some state. So let's say this returns the new dial and count, right? So like 2 I32s, and this doesn't do anything yet. So let's just, so this is spin, and spin is what we're going to test. Spin is going to take a dial, and spin is going to do something like spin 50, negative 260. So this is like a left turn of 260, right? And this is going to return to us from 50, 90, and 3, right? These are the numbers. We want 90 and 3 for spin 50, negative 260, right? Starting dial, rotation. So let new position, or new dial, new position is dial plus rotation. And then new position over, I guess we can have some consts here. This is dial total. I don't know what to call this. 100, right? So this is let revolutions is new pause over dial total, right? This isn't new position. This is dial long. I don't know what to call this. We're going to call this like the full number, right? Dial long. Revolutions is the dial long over the dial total. This should give us the count. Then the question is, we need to know where we're going to be. So that's dial_long.rem Euclid dial total, right? So let's say revolution, and let's do a cargo test. And this, we're going to ignore this one as well. I'm just going to keep writing some tests here. So this is a 90 and 3 and 90 and -2. So new dial is correct. So rem Euclid is correct, right? Like this is just where we're going to be. So we can drop that in there. Don't even need to think about it anymore. And then the revolutions are our issue. So I'm just going to start playing around here a little bit, I guess. And okay, so I took some time and wrote a bunch more test cases. A test case, in fact, for every line of the input. That is, all of these lines got turned into individual test cases here, and I just worked my way through them. And it ends up that I think I just got them all to pass. And the change that I made to make them all to pass was basically, if we went in the negative direction or 0 with dial long, and the original position we were on is not 0, then we add one more to the revolution. I think this remainder was a little bit of a mislead. It was in the wrong direction, but I've just calculated this, and hopefully this is the actual answer. It is a gold star, yeah. So what I ended up with here is kind of messy because I spent a bunch of time trying to figure out the edge cases. So if I remove these logs, what we end up with is basically parsing all the directions, start at 50, our counter is 0. For every direction, this is either a positive or a negative number, which we then toss into spin. Spin is a function that handles the dial movement. It takes a dial position and a number to spin, and returns the new dial position and the number of revolutions that happened. For each of those numbers, we add them, or actually we set the new dial to the dial position, because that's just the new position, and we add the additional counters. And then once we're done going through everything, we count it all up. And the way that I did that, or rather, the spin function here takes that dial position and the rotation and returns the new dial position and the number of revolutions. The long dial position is what I'll call it, takes the current dial position and adds or subtracts based on the direction that we're turning in to give us some number. So this is like, if dial position is 0 and we rotate it to the right 360, it would be 360. If it's 0 and we rotate it to the left 70, it would be -70. So the number of revolutions we get through integer division. So we can divide that long number by the dial's total numbers. This will be negative in the left direction and positive in the right direction. So we need to get the absolute value here because we want the number of revolutions, not necessarily the direction it was revolving in. New dial here is just rem Euclid. We take this from our original part 1 answer. It just gives us the place that the dial is supposed to be, which is exactly what we need. Now we could move this down if we want to, because we don't actually do any math on it. So we can put this down here. And then the only other case here is if the starting position is not equal 0, and we are less than or equal to 0 when we add the number, which in general means that if we were at a positive number and we are now either at 0 or lower, then we add 1 to the revolution. And that's it. Then we just sum them up. To get there, I had to write a lot of tests. So that leaves us with a couple of Clippy suggestions and things like that. So let's run a cargo Clippy on this first. And there's just some unused imports. Cool. We're no longer using tracing, so we'll just get rid of that. And then I got a little distracted, but we could do rstest here as well. So here's the demo for rstest. So let's pull that in over here. We only really need one test scaffold, if you will. So we'll leave test process because this is the whole chain for test process. And then here we will do rstest with the rstest macro and a bunch of cases. These cases are all of the assert equal. So all I'm going to do here is grab all of these as far down as it makes sense to grab them. So for now, I'm just going to copy that and then comment out basically all of these tests. And these are going to turn into our test cases. So this is the number of tests that I've written. And for each of these, what I'm going to do is swap out these assert equals case. And then at the end here, we have to close off the brackets and we'll get rid of the original cases here. So we have the expected output on the left and the kind of input on the right. One thing that we might want to do here is we call spin on all of this. So let's remove that so that we get the expected output, the input, and the input. So in this case, this is the expected. We wrote this in kind of a reverse fashion, which is fine. This is I32, I32, and this is starting position, which is also an I32, and we'll do a case here for rotation, which is also an I32. And unless I messed up my syntax, I don't think we need these semi. So we've got all these cases. We've got a test that we're going to write here. And the test is literally just this assert equals, and it is going to be expected spin starting position. So now when we run cargo test, we still get 22 tests passing, but now it is, well, it's named Fibonacci test, unfortunately. Let's say spin test, and we get a whole number of spin test cases. And this makes it easier to write more cases. We could write as many as we wanted to. And it's kind of a little bit self-documenting in the sense that this is the expected. We've got the starting position and the rotation. We can write as many of them as we want. And we get a lot of utility out of getting repeated testing boilerplate that we've written. So we've got one test that kind of does a full input. And then we have a bunch of test cases that are individual steps, which is really nice. So unfortunately, this is going to be a massive commit because I forgot to commit earlier. I'll call this day 1 in friends, and I'll push that up. And I still feel like there's a little bit we could do to clean this up. For example, in part 2, we did this little abstraction here where the number is matched on direction left or right, and we get left is negative and right is positive. In which case, we don't need to do the match here, and we can just say dial equals dial minus num. And if we run part 1, 1059, that was our answer, I happen to remember. Cleans up those match branches a little bit. And of course, anytime that you think about writing an iterator and maintaining a little bit of state that you really only need at the end, that can be written as a fold as well. So in this case, if we start with iterating over directions and we can fold with a starting position, which we haven't defined yet, I'm going to define this as a constant. Const starting position I32 is 50. That's just where we start all the time. That's what this number used to be. And then counter always starts at 0. And we could do something like dial and counter here, just to make it a little bit more clear. We'll name this direction as well. We'll say next dial is dial minus num rem Euclid. We'll say next dial equals 0. We need to be returning dial and counter here. In this case, next dial. And we can actually just shove this right in here or keep it out. We could also do additional counters, let's say, equals this if, and this will be 1 or 0 as counter plus additional counters. And let's comment out this for loop up here, and we end up with final position and counter. We don't use final position, so we'll just underscore it. We should be able to run this again and get 1059. This is the logic we just had, but written as a fold, which is also kind of nice because we could take this function here and actually just put it somewhere else if we wanted to. So we've got a fold with a starting position and 0. We've got the accumulated values, the dial and the counter, and our next direction. We match on the direction, give our num. We get our next dial position. If next dial is 0, then we have to add 1 to the counter. Otherwise, 0. And we return next dial and counter plus additional counters. We could do a similar thing to part 2, especially since we've already broken out this spin, right? Spin takes the previous state effectively and the next state. So you could see how that could also be written as a fold. And that's it for today. I will see you tomorrow for day 2. Have a great rest of your day.